In this lesson, we're going to be talking about the Pythagorean theorem, which we have already talked about, but this is a more formal version of it. So let's take a look before we get going on the Pythagorean theorem about what triangle it talks about. The Pythagorean theorem only works in right triangles. So remember what a right triangle is. It has to have one 90-degree angle. We also have to make sure we understand how to label the parts of a triangle. So the side opposite this right angle is always, always, always your longest side. And that is called the hypotenuse. So side C is called the hypotenuse. Always the longest side. Sides A and B are called the legs. So that's the first thing we have to understand, is that C, always the longest sides, the hypotenuse, A and B are called the legs. Now, the Pythagorean theorem is used to find a missing side on a right triangle. Remember, this only works when you have a right triangle. So all it really allows us to do is find out what is the measure of one of the sides. And the formula is A squared plus B squared equals C squared. And we're going to talk about what that means when we get to an example. So let's take a look at one. So this is really what A squared plus B squared equals C squared means. So Pythagoras, who invented this formula, said that if you squared the legs of a side, so let's say we square this. So if this length is 5 and this length is 5, the area of this square is 25. Okay? And then he said, if you square the other side, the other leg, so this is 12 and this is 12, so this would be 144. So Pythagoras says, okay, let's take the square of the sides, 5 squared, and add it to the square of the other leg, 12 squared, and that is going to equal the square of this guy. Okay? So that's going to equal 169. If you take the squares, you add them up, that's 169, right? So I don't care that this is 169. I just don't. I want to know the length of the leg. So how would we do that? We take the square root of 169, and that's how we get 13. Okay, so let's take a look at that formula. It says you add 25, and then you add 144, and that is going to equal this whole area of the hypotenuse, right? But I don't care about the whole part. I just want the square, so we take the square root, and we get x equals 13. Now, clearly, we don't have to draw a picture every single time, but I really think it helps with the visual. So let's take a look at number 3. Remember what he said. If you square the legs, 29 squared, that's a leg, and you add 14 squared, that's going to equal the hypotenuse squared. So we take our calculator, and we do 29 squared plus 14 squared, and we get 1,037 equals x squared. I don't care about the square of it. I want the square root because I just want one length of the side. So when I do that in my calculator, I get x is going to be 32.2. Now, for delta math, you guys are going to do a different level of it. So you're actually going to have to simplify the square root, which we've done before. So for the purposes of this video, I'm just plugging it into the calculator. We can get a decimal and then round 2 places to get to the hundreds. All right, now, how do we find a missing leg? I know how to find the hypotenuse. How do we find a missing leg? It's the same thing. You square this leg, you add it to the square of this leg, and that's going to equal the square of the hypotenuse. And then we just get x squared by itself. So we're going to subtract 8 squared on both sides. So I get 10 squared minus 8 squared. So then x squared is going to be 100 minus 64, which is 36. But I don't care about the whole area being 36. I just want one leg. So I'm going to take the square root, and x is going to equal 6. So as long as you have that formula and you just kind of plug in the numbers, you're going to be good to go. Let's do page 2. Let's go on to the next page. Okay, let's take a look. So when they're mixed in, let's do 11 and 12. So here I'm looking for the side, but my formula is the same. So it's this side, this leg squared, plus this leg squared, and that's going to equal the hypotenuse squared. So I have x squared plus 25 equals 49. Subtract 25 from both sides. X squared equals 24. And when I take the square root, I am going to get 4.9 is my answer. Okay, let's look at number 12. Same formula. I take this leg and I square it. I add to that this leg and I square it. And that's going to equal my hypotenuse squared. So 17 squared is 289 plus 144. And that's going to equal x squared. When I add that together, I get 433 equals x squared. And I don't care about the square, so I'm going to take the square root. So x equals 20.8. Okay? All right. Now, let's look down here. And if we're testing for whether or not it's a right triangle, all we're going to do is we're going to use the formula. Remember, hypotenuse is always your longest side. Always. So I'm just going to use the formula and test for equality. So 10 squared plus 15 squared equals 20 squared. And I'm going to type that into my calculator, and I get 100 plus 225, and does that equal 400? 325 does not equal 400, so no. This is not a right triangle. All right, let's look at number 6. So over here, I get 7 squared plus 24 squared equals 25 squared. Again, remembering hypotenuse is always the longest side. So I get 49 plus 576 equals 625. And when I add these together, I get 625 equals 625. So yes, that is a true statement. So yes, it is a right triangle. So, quick lesson on Pythagorean theorem. If you have questions, let me know.